Hey guys, so in the last video we started talking about Pythagorean theorem, which if you all remember is a squared plus b squared equals c squared. We're going to extend that idea just a little bit because sometimes you're not always going to be given all three of the side lengths. So go ahead and draw you a nice right triangle, okay? Because we're going to assume that we're working with a right triangle to start, all right? And then you'll be given two of the sides. So let's put a 9 here. And obviously this is not to scale, okay? But we're going to put a 12 on the bottom, all right? Now, the question is going to ask you to find the missing side length, all right? So first you got to figure out, well, which side length am I missing? Is it A, B, or C? Now, between A and B, there's some leeway. It doesn't really matter. You can flip which one's A and B. But C will always remain the same. So C is the longest length of the right triangle, and the easiest way to find it on a picture is to look across from the right angle. So wherever this right angle happens, okay, that 90 degree, you go across from there, that's going to be your hypotenuse. So, in this case, we are missing C. All right, so let's go ahead and model that with our equation. So we got 9 squared to represent a squared. All right, we're going to use 12 squared for b squared. And then this is the side that we're missing. So we're just going to write c squared, since that's what we're looking for. Now it's just like any problem where you're solving for a variable. All right, you're going to simplify first. All right, our awesome PEMDAS tells us that we need to settle any exponents before we move on because there's no parentheses. All right, so 9 squared is going to give us 81, right? 12 squared will give us 144, and we still can't do anything with c squared yet. All right, so let's simplify this a little further. 81 plus 44 is going to give us 225. Equal to c squared. Now, if we're saying that c squared equals 225, in order to do the opposite operation here, we need to do the square root on both sides, because the opposite operation of squaring something is to take the square root. All right? So, on the left side, we've got the square root of 225, which if you type in, that's going to be 15. Now, I know we talked about this being plus or minus 15. However, we're talking about a length of a triangle. We can't have negative length. So it's just going to be positive 15 equals the square root undoes the square to give us c. So that is our missing side length. All right, so let's look at another example, except this time we're going to be given that this is 12, this is 20, here, and that this is our missing side. All right, so now when we look across from the right angle, we actually have our hypotenuse this time. Okay, we're missing either A or B. It doesn't really matter what we call it, but let's just call it B since that's what we've been putting on the bottom. Okay, so if we're going to model this, A is going to be our 12, so 12 squared plus, we don't know what b is, so let's put b squared. And then we know what c this time is, so we're going to put 20 squared over here. All right? Now it becomes solving for b rather than solving for c like we did last time. So 12 squared is 144. We don't know what b squared is. Equals 20 squared, which is going to be 400. All right. Now, in order to get b by itself, we need to get rid of anything that's attached to it. So that would be this 144. So we're going to subtract 144 from both sides. All right. That cancels out over here. You end up with just b squared equals 400 minus 144 is 256. All right. And then to undo this square on the b, we're going to do the square root on both sides. Okay, that undoes over here, so we just end up with b. equals the square root of 256, which is 16. So we know that our missing side length is 16. All right, so this last example, I'm going to use some decimals because that's what you're going to see on your practice problems and your STAR test. So I'm going to give you the hypotenuse as 10.4, and we're going to give you this bottom length here, which is 7.3. So this would be our missing side length over here, right? So let's model this one more time. We're going to call this A again. So we don't know what A is. We'll just put A squared. No problem. We know what B is, 7.3, so we're going to put 7.3 squared equals C squared, which is 10.4 in this case. 10.4 squared. Now, obviously, I don't have 7.3 squared or 10.4 squared memorized, but this is something you can really easily type in your calculator, which I've already done. I've got a little cheat sheet, so if you see me doing this in my head, don't worry. It's not just because I'm super smart, which I am, but not on memorizing decimal squares. So, A squared, can't do anything with that. 7.3 squared, I typed in and I got 53.29. Alright, you can check my work if you like. 10.4 squared got me 108.16. Alright, now to get A squared by itself, we need to get rid of anything attached to it, which is this 53.29. So you guessed it, we're going to subtract it from both sides. Okay, so it cancels out over here, and you just end up with A squared equals 108.16 minus 53.29 gave me 54.87. Okay, and then the last step, to undo this square, we're going to take the square root. And if you do something on one side, you got to do it to both. I know this looks ugly, but when we get that ugly number, we're going to actually round to the nearest hundredths place. So on the left side, we end up with A. And then on the right side, I got 7.41. Okay? And again, I'm rounding. It goes on a while. It probably goes on forever. But if we round, we get a nice 7.41.